Hi and welcome back to the section for today. So today we want to have a business statistics Q&A section. This is going to be more of question and answers. Going to throw in some formulas, things that we need to know. So far as business stat exams is concerned, key areas you want to understand when it comes to the introductory part of statistics. Going forward, talking about classifications of data, measures of location or central tendency, measures of dispersion. Then we talk a bit about other measures like skewness, kurtosis, moment, and then we jump also a bit to that of correlation and regression, looking at how we can determine the strength of what two variables. And then we know their variations variations that exist between the data by taking into account coefficients of determination and those issues there. Then we also jump to discuss a bit about probabilities and statistics generally there. So this is going to be the part one of the section for business statistics Q&A. So as we move along, any question you have, you want to throw in a chat, and make sure you like the video, you share with your friends as well in that case. So this was just an emergent, live Q&A session for me to come in based on the number of questions I've received on the topic. So we'll start from the classifications of data. But I know the introductory part, there's nothing, that you can naturally go through. All of them are clear for you to understand. But we'll start with the introductory, the classifications of data issue there. If you just join us, do all to like and then share the video so that others will get the benefit too. Join us generally there. So we're gonna start with the classifications of data. So classification. So under the classification, these are the things that we're supposed to know, especially when it comes to how we calculate the midpoint of a data, how we calculate class boundary, how we calculate using Sturge's rule to calculate the class mark or the class limit in that particular. So we'll first start from how we calculate what the midpoint. So let's say I have this data. So let's say I have from 1 to 3, 4 to 6, then 7 to 9, then 10 to say 12. If I'm asked to calculate the midpoint of this data, this is a group data. This is a group data because we have what we call as a class mark or class interval. So these are the marks for the data. Okay. So if I'm asked to calculate the midpoint of this data, midpoint will naturally employ midpoint straight up going to have upper limit or upper class interval added to the lower class interval general there. So upper limit plus lower limit and then divided by 2. That will give us a midpoint. So we'll say that the midpoint of the first one will have 1 plus 3 divided by 2. We're going to get 4 over 2 as opposed to get 2. So we'll have here as 2 as our midpoint. When it comes to group data, you may want to have the midpoint as the values of x that we can use to multiply the frequencies so that we can then naturally find that of the f of x. Use that together with the f so that we can find the mean generally there. Okay, so we will have 1 and 3 added, you get 4 divided by 2. Likewise, 4 by 6 added 2, you get 10 divided by 2, you get 5. So once you're able to get the first 2, now you can clearly see that as always, if you want to use this method I'm about to teach you, as always, you must always check it that the class mark that you see here, okay, is supposed to have the same equal class the class size generally there. So that you can use the method I'm about to teach you. So here I can deduce that they all have the same class size or class width. So what I will do here is that here the difference between 2 and 5 is 3. So that means that the next value for the midpoint is supposed to be 3 in addition to the 5 here, and that will give me the next midpoint. So I will have 3 added to 5, and that will fetch me 8. You can text 7 plus 9 get 16 divided by 2, 8. So here too, 3 by 8 supposed to added to 8 supposed to get what? 11. You can check as well. 10 plus 12, you get what? 22 divided by 2, you get 11. So this is how we calculate what? The midpoint of the data. So once you get the midpoint, that is perfect. So the next thing we want also to look at is this, how we get the midpoint. The next thing we want to look at is also how we calculate what? The class boundary. How we calculate the class boundary is also very, very important as part of the discussion. So using this data above to calculate the class boundary, as always, you expect that you get equal class size. Equal class size. So class boundary. So class boundary here will factor in what? As always, has to do with what? You want to get a common point that will mark what? Between the class what? Limit. So here we have 3, here we have 4, here we have 6, here we have 7, here we have 9, here we have what? 10 here. So how are we going to compare what? The upper limit of a particular class compared with the lower limit of what? The next succeeding class. So for instance, if I should take the second class limit here, which is 4 to 6, the upper class limit is what? 6, and the lower class limit is 4. When we check the next succeeding class, which is 7 and 9, the lower class limit is what? 7. So I'll find the difference between 6 and what? 7. So 7 minus 6. 7 minus 6 supposed to get what? 1. So once I get 1, the next thing I want to do is to divide the 1 by what? 2. And that's going to give me what? 0.5. So this is the common point that will set a mark between what? The class what? Limit or the class mark. So what do I do for me to get my class boundary? All that I will do here is to subtract 0.5 from the lower class limit of all the class and then add 0.5 to the upper class limit of all the class. Okay, so 0.5 subtracting from 1 is supposed to get what? 0.5. Okay, you get 0.5 to, then you add 0.5 to 3, you get what? 3.5. So you do the same thing to all the classes. So you get here to what? 3.5 to what? 6.5. Likewise here, you get 6.5 to 9.5. Then here you get 9.5 to 11.5. This is how you calculate what? The class boundary for a particular class. So let's take note of that. So once you have the class boundary coming up, the next thing we also want to calculate is also how we calculate what the class what size or the class width. So how do you go with the class size or the class? So class size or width supposed to be equal to what? The difference between what? The upper class boundary compared with what? The lower class boundary of all the class. Okay, so let me try to pull this up here for you. So let's say there's a class size. Okay, so the difference between the upper class boundary and then compare with the lower class boundary. So here 3.5 minus 0.5 is supposed to get what? 3. All right, supposed to get what? 3. Likewise here too, the difference between 6.5 and 3.5 is supposed to get what? 3. So you can calculate that the class size is 3 throughout. All right. So once you have that, that is true. This is how we calculate what? The class size or the class width. Then also we also want to calculate, what we call the max less than. The max less than is also very crucial, or max more than or less than. So that one will chip in where we have the frequency come. So let's say we have, these are frequencies F. Let's say for the first class we're having 2. Okay, let me use 2. Let's say here is 2, 4, 6, 3. So total frequency supposed to have what? Supposed to have 2 plus 4, 6, 6. And I have here as 12, 15. So to calculate what we call the max less than, or what we call the cumulative frequency, using the max less than approach, cumulative frequency, all I want to do is that within the class 1 to 3 as a class limit, the frequency we have is 2. So that means we have 2 as our frequency there. The next thing you want to do for the next class 4 to 6, the cumulative frequency is supposed to be the addition of what the previous frequency plus the current frequency, which is what 4. So that'll give me what 6. For me to get my next cumulative frequency for the third class, supposed to be the previous cumulative frequency, which is 6, plus the current one, which is what 6 for the frequency, you get 12. And then lastly, the 12 by added to 3 is supposed to get what 15. As always, for you to know that your cumulative frequency is right, your last value for the cumulative frequency is supposed to be equal to that of what? The total frequency that we have, total frequency that we have generally here. So you see that it is equal to, so that means our cumulative frequency was true. This is how you do cumulative frequency. And then we also want to look at how we also calculate what we call the range of a data under the classification using Sturge's rule. We want to know how to calculate the range of a data. So how do you calculate range of a data? So to calculate range of a data, we said range should be equal to the highest value compared with the lowest value. Okay, highest value compared with the lowest value. So as always, you'll be given a data, then the highest value compared with the lowest value, that will give you the range. Okay, then once you know how to calculate the range, so let's say we have this data coming up. Let me try to bring in an ungroup data so that we can use that to perform some value calculation here. So let's say we have 10, 11, 13, 14. Let's say we have 9, 8, 10, 15. Let's say we have 12. Let's say we have 14, 14. Let's say we have 15. Just 15 set of data, right? So here you can clearly see that the highest value in this data is what 15. Okay, and then the lowest value in this set of data is what 8. So when we take the 2, that will give us what the range. So range should be equal to 15 minus what 15 minus what minus 8, and that will give us a value of what is it 7? Yeah, you get 7 as your range. So once you know the range, we also want to know how we calculate what the number of classes desired. Number of classes desired. To calculate number of classes desired, for us to use to construct this group data we have here, for instance, example like these ones, is very simple. So that means we're going to apply what we call the Sturge's rule. So Sturge's states that it's supposed to be 1 plus 3.322 log to the base of what? N. So log n to the base of 10, rather. So once we have this, then we can say that, let's count the number of frequencies that we have here. We have what? 1, 2, 3, 4. 1, 2, 3. So that means on each column we have 4, on each row we have 3. So that means set of data is what? 12. So we can say that Sturge's rule will have what? 1 plus 3.322 log. So we have 12, okay, as our number, and the base is what? 10. So with the help of our calculator, we're supposed to be able to do this and then get the answer, and that will give us what? The value of. So drop in a comment for your answer for the Sturge's rule, and let's see if that's true. So that is the whole idea when it comes to the Sturge's rule. So once we also know the Sturge's rule, then we are good to what? Go. So once we have the Sturge's rule, then for us to calculate the what we call the width of the class using this ungroup data to calculate the width of the class or class size. So class size or width is supposed to be equal to what? The range divided by the number of classes desired divided by what? The Sturge's rule formula that we have. So that divided by the Sturge's rule. So I'll say Sturge's rule, something of that sort. Okay. Well, the value you're going to get is the number of classes desired. So I'll represent that as Sturge's rule. Whatever you get here, okay, will be the number going to substitute in the Sturge's rule. Then you get the class width or class or size. So some of these values or some of these stuff, once you get it right, you are good to go generally there. Okay, so once we have that, then we are good to go. Then the next thing you want to do is also know how you can calculate what the class limit. The class limit once you know the class size. All right. So as always, you go back to the data. What is the lowest value of the set of data? The lowest value is 8. So that means you're going to start from what? 8. The first class limit will begin with a lower limit of 8. And you ask yourself, let's assume that the class weight you have something like let's say 2. So that means that for us to get the difference between the lower class limit, which is the 8, and the next upper class limit of the first class, and let's assume that our number of classes that we have, like say 4. Let's assume that we had 4. Okay, so I'm gonna have what? A class limit of what? 4. I mean the class limits. You're gonna have what? The number of classes you're gonna have 4. So the lower class or the lower value is 8, and that means that for me to get my upper class limit for the first class, all that I would do is that the difference in between the lower class limit, which is 8, and the upper class I'm about to derive supposed to be 2. So that means that I will say that it's supposed to be what? 8 to what? 9. That means for me to get the 2, I will count what the the upper limit, this lower limit of 8, and then this upper limit together. In terms of counts, I'll count them so that I'll get 2. So that means 8 and what? 9 is 2. Okay, and the next one is supposed to be what? 10 to. Supposed one to be 10 to what? 11. Like you can check. So assuming we have this, then like say here we have 12 to 13. Then last one, like say we have what? 14 to 15. Let's see if the class size is true for this class. Limits that we have produced, or the number of classes we have produced as an interval. Let's see if that is true. So here I want to calculate what? My class boundary. So as usual, 9 from 10 will get what? 1 divided by 2, get 0.5. So we subtract from here, we'll get 7.5. Then we add to 9.5, we'll get what? 9.5. So the difference between 9.5 and 7.5, we're going to get what? So here is 0, here is 2. So now you see that when we're making the assumption that let's say the class size is 2, you see what we're going to get. So that means to form the number of classes that we're supposed to have as a class interval, all that I want to do is, for you to see that is correct, you are going to consider the class width or the class size, right? And you add that to that of what? The lowest value in the set of data. For example, in this case was 8. So once you have that, then it means for you to get to know that it is 2, for instance here, supposed to count that of the lower value and then the upper value going to develop. It's very simple. Okay, and that will urge you for you to get the rest. All right, so that is something that you need to know when it comes to this. I think there's some comment here. Esther said that it's 4.58. Okay, that's fine. But we are just using this as a guinea pig to explain all the concepts, so it shouldn't be a problem if you get any value at all. All right, so let's take note of that. Then you develop your class intervals and you are good to go. And then also how you also calculate what we call percentage frequency. For instance, let's say I'm asked to calculate the percentage frequency of what? That of what? 4, which is what? In the, for instance, this one, let's say it's in the what? The second class interval 4. So how do I get that? So I can say that the percentage frequency for the second class, which is 4 to what? 6, supposed to be equal to 4 over what? The total frequency supposed 15, then multiply by what? 100. Whatever I'll get will then give me my percentage frequency for the second what? Class interval. For the second class interval, like that. You are good to go. Some of these things very simple and easy to go. So we'll end our section for today here, okay, and we'll continue the part 2 tomorrow, where we'll continue from here, take on the formulas that you're supposed to know before as your exams are approaching, touch on all areas so that you understand basically. So that's what we're going to do towards your exams. So do want to share the video and then like it as well. I wish you the best in your upcoming exams, and I'll see you. Bye bye.